Good morning. So today we are going over graphing rational expressions. So we are going to start with our parent graph. So consider the function 1 over x, right? You can think of it as y equals 1 over x. So let's start with the table. So let's plug in some values. So if you plug in 1 for x, 1 over 1, you get 1. You plug in 7, you get 1/7. If you plug in 1/5, that's division, so that's really 1 times 5 over 1, so it's 5. If you plug in a -1, you just get -1. Plug in -7, you get -1/7. And if you plug in a -1/5, remember that's 1 times 5 over 1, so you get -5. So let's plot those points to the best of our ability. So 1, 1. All right, 7, 1/7. All right, 1/5, 5. Okay, and then -1, -1, -7, 1/7, and then -1/5, 5, -5. So let's connect those. So there's our graph. All right, so that's the parent function. So every graph we do for the rest of this unit is going to be based off of this graph right here that's on your screen. So like every graph we've done, we've always had what we call like a key point. Sometimes it had a specific name like the vertex. Other times we just called it, the most important point, the key point, the starting point. So the most important point for this graph is the origin, 0, 0. The graph is centered around the origin. Some other special points would be these two that are in green right there. So 1, 1 and -1, -1. Notice they're both 1 unit away. Right one up one, left one down one, but they're 1 unit away. So those are going to be some helpful points I'll reference later. So notice it never touches the x or y axes. All right, so it never touches it. These are called asymptotes. So the equation for the horizontal asymptote, so the asymptote that I'm putting in green, right there, right, that is a horizontal line at 0, so it would be y equals 0. There's the vertical asymptote, right, that I'm doing in red. So that would be x equals 0 for the vertical asymptote. So these graphs will always have a vertical and horizontal asymptote, a line that our graph gets close to but never touches. All right, where is the graph increasing? So as you look left to right, does the graph ever go up? It goes down and then down, so it doesn't. Right? It does not increase. Does it decrease? Yes, it's decreasing across the entire domain. So that would be from -infinity to 0, skipping 0, and then continuing on. Because it decreases everywhere other than 0 because there's an asymptote at 0. Where is the graph less than 0? So for us, 0 again would be the green dashed line. So it's less than 0 from -infinity to 0. Where is it greater than 0? So where is it above the green line? Well, that would be from 0 to infinity. Right? So that would be, if you were coloring the graph, the dark green part here that I'm coloring, that is above 0. Right? The part I'm doing in purple here, that would be below 0. So the purple part, that is the less than 0 part. The green part is the greater than 0. So what's your domain? Well, your domain is every number but 0. So -infinity to 0. Union, because we have to skip 0. What's your range? Every number, right? It goes all the way down to negative infinity. It skips at 0, then keeps going on. So it's every number but 0 as well. So you have to have a union. So notice, what values am I skipping? I'm skipping the asymptote. So the domain and range is every number but the asymptotes, because you have to skip those. So use the definition of the y-intercept to demonstrate why the y-intercept does not exist. So to find the y-intercept, right, we let x equal 0. So our equation is y equals 1 over x. So if x is 0, we get y over 0, right? That's undefined, right? Fraction with the 0 is undefined. So that's why there's no y-intercept. Use the definition of x-intercept to demonstrate why the x-intercept does not exist. Right? We're doing this by define the x-intercept. You let y equals 0. So y equals 1 over x. So y is 0. Okay. So now, is there any way to get a fraction to become 0? Well, something like, well, put 0 up for x. Well, we just did that. It's undefined. So no matter what number I put there, 1 over x will never equal 0. No matter what number goes in there for x. Fraction, negative number, positive number, it will never be 0. So that's why there's no x-intercept. Wait, so let's look at example 1. So we have y equals 1 over x minus 3. Remember, the parent function's y equals 1 over x. So this has been shifted. So it's been shifted 3 units to the right. So now the key point is 3, 0. So which asymptote moved? Well, it moved right, so that would be the vertical asymptote moved. So now you have an asymptote at 3. You still have the horizontal asymptote at 0. So it's been shifted right 3. So the vertical asymptote is now at 3. The horizontal asymptote is still at 0. And why is it shifted? Because of the x minus 3. And it's the same idea that we've talked about with shifting back in Unit 1. It's positive 3 makes that equal to 0, so it's been shifted right 3. So this graph is still not going to have an x-intercept. But it's now going to have a y-intercept because it's been shifted right, and now it's going to cross. So to sketch the graph, all right, we're going to have to figure out what is that y-intercept. So to find the y-intercept, we're going to let x equal 0. So we have 1 over 0 minus 3, so it's negative 1/3. So it's there. Now remember, I talked to you about those 2 key points, or those other like special points, 1, 1 and -1, -1. So since this is a 1, right, I can go to that new key point that was 3, 0 right there. I can go right 1 and up 1. I can go left 1 and down 1. And those are 2 free points I can get every time because that's a 1. So now I can sketch my graph. So it looks like this. Comes down. And I know it's going to be really close to both asymptotes. So once I have that important point, right, that's where my asymptotes are going to go through that point every time. So once I get that, I have my asymptotes. I know I can go back to that key point, go right 1, up 1, back to that key point, left 1, down 1. I will always get those other 2 points as long as that's a 1. All right, where is the graph less than 0? So less than 0 would be the blue part of the graph right there. So that would be from negative infinity all the way to 3. Or is it greater than 0? That would be the purple part of the graph. So that is from 3 to infinity. Okay, example 2. So we have our function here. So remember, this type of notation means you're going to plug G into F. So your new equation, right, G is going to go in for X is 1 over X plus 4 minus 5. So this has been shifted left 4 down 5. So left 4 down 5. So that's where your asymptotes are. So your horizontal asymptote is now down at -5. Your vertical asymptote is at -4. Right? That's kind of like your new little key point right there. This is where the asymptotes intersect, that key point. So it's been shifted left 4, down 5, just like we dealt with all of our shifting in Unit 1. What makes x plus 4 equal to 0? -4. The y is the same, up and down, x is left and right. Okay. So now it's saying, does the graph have a y-intercept? Nope. Right? And how do I know that? Well, I know my key point or my other special points are 1 to the right and up 1, 1 to the left and down 1. So the graph does this. The graph does that. So it does have an actual y-intercept. Right? So we can't always make that assumption until we sketch our graph. So to find the y-intercept, right, x is going to be 0. So 1 over 0 plus 4 minus 5. So 1/4 of minus 5. Right? If you know anything with fractions, you're taking 1/4 from 5. So it's 4 3/4, but it's negative. So 1/4 from 5, right? If you have $5, you can take a quarter away. You have $4.75. It's the same idea. So it's -4 3/4. Which is about right where I have it. Right? So there we go. Okay. So now the next thing, right? Does it have an x-intercept? Yes, it does. We can see that. So to find the x-intercept, the y has got to be 0. So 0 equals 1 over x plus 4 minus 5. So I need to get x by itself. So I got to get rid of the fraction eventually. But before I do that, I want to move the 5 over by adding it. Okay, now I have a proportion. How do you solve proportions? Right, multiply diagonally across. So 5 times x plus 4 equals 1. Distribute 5x plus 20 equals 1. Now I'm going to subtract 20. I get -19. Divide by 5. So -19 over 5. Which, again, if you wanted to, you could convert that to a decimal if it makes a little more sense to you. So that's x is -3.8. So almost 4. Which makes sense because I have 1, 2, 3. I'm almost at 4, which is where my dot is. Okay, so I have my x-intercept, my y-intercept. I have my sketch. So where is the graph increasing? As you look left to right, does the graph ever go up? It goes down, it goes down. So it's not. Where's it decreasing? Well, it's not increasing, it's decreasing everywhere then. So the domain would be everything but -4. We have to skip -4. So I just also answered the domain question because these functions are going to do one or the other. They're going to either increase everywhere or decrease everywhere. So this is decreasing everywhere, so it's across the entire domain. So when you answer the question, where is it decreasing, you're also answering the domain question. It's a 2-for-1 deal. The exact same answer. Well, might as well do the range then. So the range is everything but -5, right? It starts down at -infinity, gets to -5. Then we have to skip -5 and then keep going. How do I know I'm skipping? Because there's the asymptote that I'm coloring in green right now, right? We skipped that value. It's at -5. Okay, so here comes the tricky part, right? Where is the graph less than 0? Well, it's this entire blue piece, but it's also this blue piece here. So it's negative infinity to negative 4. Okay. Now, it starts being below 0 again at I'm going to do it in lime green, that lime green dot. Well, that's negative 3.8. And then it keeps going on forever to the right, being below 0. Right? All the blue graph is below 0. So I have to write that interval. So negative infinity to negative 4 is the first part of the blue graph. The other part of the blue is from negative 3.8 to the right. So negative 3.8 to infinity. And then the last part, where is it greater than 0? So there's a little chunk right up here. Right? So that's from negative 4 to negative 3.8. So that little piece is greater than 0. That little red piece up there. So again, as you're graphing these, the main thing is realizing the shift concept is the same that it was for Unit 1. Right? X values, right, go left and right, shift it left and right. Y values up and down. Right? Opposite for X, same for Y to figure out the shift. Now, where the shift is where your asymptotes intersect. Right? So this is shifted left 4, down 5. So that's why the asymptotes intersect right there at negative 4, negative 5. How do I get my two little free points here that I'm coloring red on the graph? They're always going to be over 1, up 1, over 1, down 1, as long as you have a 1 in the numerator. So all you need to do is answer the essential question at the top of the notes with a 3 to 5 sentence summary, and then you'll be done with your notes. Have a great day.